Forget everything you think you know about Tyrannosaurus rex. Those movies got a lot right, but they got a lot wrong too. What was the real T-Rex like? It was weirder, cooler, and frankly more terrifying than Hollywood ever dared to imagine. From a bite that could crush a car to senses sharper than any modern predator, to a social life that might surprise you, the Tyrant Lizard King was a creature of extremes. Today, we're diving into the 10 mosts that made the T-Rex the undisputed champion of its time. Unveiling the real T-Rex. For millions of years, from about 70 to 66 million years ago, in what is now North America, one creature stood head and shoulders above the rest: Tyrannosaurus rex. It was the apex predator of the Late Cretaceous period, a time when dinosaurs still reigned supreme right before that infamous asteroid decided to change everything. But what made this giant so dominant? Was it just brute strength, or something more subtle, more specialized? Today, scientists are digging deep into the fossil record, sifting through bones, bite marks, and the latest research to uncover the 10 mosts that truly define this king. Science is always evolving, and our understanding of the T-Rex is no exception. What we thought yesterday might be refined today thanks to incredible new discoveries. This shows that paleontology isn't a static field of old bones, but a vibrant one of constant discovery, making this content even more current and exciting. Let's embark on this journey to discover the king through the 10 mosts of the T-Rex. 1. The strongest bite on the planet. Let's start with the obvious, but also the most incredible. The T-Rex possessed the strongest bite force of all land animals ever to exist. Imagine this. An adult T-Rex could clamp down with a force of 35,000 to 57,000 newtons at a back tooth. To put that in perspective, that's like an adult African elephant sitting on you, or if you prefer pounds per square inch, PSI, we're talking 8,000 to 12,000 psi. This pressure is so immense, it's equivalent to 1/128th the pressure at the center of the Earth. Or, a hydraulic press used to crush cars only generates about 2,000 psi. This wasn't just a strong bite, it was a bone-crushing bite. Unlike most reptiles whose teeth are designed for slicing, T-Rex teeth were like giant banana-shaped railroad spikes. They were thick from side to side, with tooth roots twice as long as the crown, built to withstand immense pressure. Researchers have found that the T-Rex could initiate cracks in bones by repeatedly biting down, much like mammals do, leading to catastrophic failures of bone. This allowed them to exploit every last nutrient, including bone marrow, that other carnivores couldn't access. This ability suggests a highly efficient feeding strategy, potentially helping it thrive even when prey was scarce. By accessing bone marrow and mineral salts, the T-Rex could utilize parts of a carcass that other predators couldn't, minimizing competition and maximizing energy intake. Even juvenile T-Rexes, despite their bite force being only about 5,641 newtons, somewhere between a hyena and an alligator, already practiced this bone-piercing technique, building strength for adulthood. The dramatic increase in their bite force during development suggests a shift in their feeding behavior as they grew. This means their diet and hunting methods likely changed significantly with age, reducing competition between different age groups within the same species. 2. The most superpowered sense of smell. If the T-Rex had a dating profile, its greatest strength section would definitely include exceptionally keen sense of smell. Forget your average bloodhound. The T-Rex was the prehistoric equivalent of a super scent detective. Scientists studying T-Rex brains, or rather the fossilized cavities where their brains once resided, found unusually large olfactory bulbs. This indicates that a significant portion of its brain was dedicated to processing odors. This wasn't just a good nose, it was a superpower nose, capable of detecting prey or carrion from miles away. Think of it as a built-in long-range radar system for finding dinner. This acute sense of smell was once a key piece of evidence used to argue that the T-Rex was primarily a scavenger like a giant vulture. However, modern research suggests that large olfactory lobes are also crucial for predators to track mobile, dispersed prey. This highlights how the same data can be reinterpreted with new understanding, shifting scientific consensus. This shift in interpretation is a clear example of how science self-corrects and evolves as more information or new research methods become available. 3. The best infrasound listener. Forget the Hollywood roar, that piercing, ear-splitting sound you hear in the movies. the real T-Rex likely didn't roar like a lion. Instead, it might have communicated using something far more subtle and perhaps even more terrifying: infrasound. Infrasound refers to sounds so deep, so low in frequency, that human ears can't hear them. But the T-Rex, thanks to its super-sensitive inner ear structure, specifically the cochlea, found in fossilized skulls, could both produce and perceive these vibrations. Imagine a multi-ton creature letting out a deep rumble that you don't hear, but you feel the vibration reverberating through the ground, through your very bones. Modern alligators, close relatives of dinosaurs, do this with their mouths closed, causing the water around them to dance. T-Rex, 15 times larger than an alligator, could have generated ground-shaking vibrations, traveling for miles, communicating with other T-Rexes, defending territory, or even attracting mates, all without making a sound we could perceive. This ability to sense and generate infrasound paints a picture of a sensory world vastly different from our own. It implies a sophisticated, long-range communication system that didn't rely on visual cues or loud, high-frequency sounds which would be easily absorbed by dense forest environments. This challenges the loud, roaring monster image and suggests a more subtle, strategic predator. A silent, vibrating presence was likely more terrifying and effective for a large predator than a loud roar that would alert prey. 4. The sharpest 3D vision. Contrary to popular movie misconceptions, like Jurassic Park, the T-Rex did not have poor eyesight that relied on movement. In fact, it had some of the best vision among land animals of its time. Unlike most dinosaurs that had eyes on the sides of their heads, the T-Rex had forward-facing eyes, giving it a binocular field of vision of up to 55 degrees. This is comparable to humans and even better than many modern birds of prey. This means it had excellent depth perception, allowing it to accurately gauge distances to its prey. Imagine a sniper with a built-in rangefinder. That was the T-Rex. Combined with massive optic lobes, the brain regions that process vision, the T-Rex was a highly visual hunter, capable of spotting and locking onto targets with incredible precision. And here's an even more surprising twist. Scientists even suspect it could see in the ultraviolet spectrum, a range of colors invisible to us. This combination of both an exceptionally keen sense of smell and superior binocular vision suggests the T-Rex was an incredibly versatile predator. It wasn't limited by a single mode of hunting, just sniffing out carcasses or just ambushing by sight. This mastery of dual senses allowed it to adapt to a wide range of hunting scenarios and different prey types, making it a truly formidable and efficient predator. 5. The heaviest land predator. When we talk about the biggest dinosaurs, many names come to mind. But when it comes to sheer bulk, the heaviest land predator ever to walk the earth, the T-Rex reigns supreme. An adult T-Rex typically measured about 40 feet long and about 12 feet tall at the hips. But what truly cemented its reputation was its weight, an astonishing 17,000 pounds, or about 9 tons. To put that in perspective, that's heavier than 2 adult African elephants stacked on top of each other, or the equivalent weight of 5 compact cars. While other carnivorous dinosaurs like Giganotosaurus might have been slightly longer, up to 41 feet, the T-Rex consistently outweighed them, making it the true heavyweight champion of land carnivores. Emphasizing bulk over just length is crucial. While length can be impressive, mass correlates directly with power, impact, and the ability to subdue large prey. This enormous weight also had significant biomechanical implications, as we'll see with its speed shaping its entire lifestyle and hunting strategy. 6. The fastest growing giant. How does an animal go from a turkey-sized hatchling to a 9-ton monster? The T-Rex underwent one of the most incredible growth spurts in the animal kingdom, putting even our most awkward teenage years to shame. Over a period of about 14 years, from roughly age 14 to 18, a teenage T-Rex would pack on an astonishing 5 pounds of weight every single day. That translates to over 1,600 pounds a year. By the time it reached its early 20s, around age 18 to 20, it had reached its full adult size, ceasing growth around 20 years old and having a relatively short lifespan, topping out at 28 years. This rapid growth rate allowed it to quickly outgrow its most vulnerable period and spend approximately 30% of its life as the undisputed apex predator. This live fast, die young strategy, as some scientists have put it, is more akin to large mammals, like elephants, which also have similar growth rates and maturation times, than other reptiles, suggesting a unique metabolic adaptation. The rapid growth rate and relatively short lifespan suggest a high-risk, high-reward life history strategy. By quickly achieving immense size, the T-Rex minimized its vulnerability as a juvenile and maximized its time dominating as a top predator, competing with smaller carnivores and even juvenile T-Rexes for larger prey. This causal relationship, fast growth greater than quick dominance greater than short intense period of reign, is a critical aspect of its evolutionary success. 7. The most mysterious arms. Ah, the arms. The punchline of every T-Rex joke. Whatever the arms were for, they weren't for passing potatoes, as paleontologist Kenneth Carpenter famously quipped. These forelimbs, barely longer than a human arm despite the T-Rex's immense size, have baffled scientists for over a century. Were they just useless evolutionary relics, like our appendix? Not so fast. Evidence suggests these tiny arms were surprisingly strong, with biceps muscles capable of lifting over 220 pounds each. And fossilized furculi, fused collarbones like in birds, show signs of healed stress fractures, implying they were subjected to extreme forces. This strongly contradicts the useless vestigial organ hypothesis and indicates they were actively used and subjected to significant strain. So, what were they for? The theories are numerous. Ripping struggling prey. The stress fractures suggest they were used to hold large, thrashing prey close, perhaps to stabilize them for a killing bite, pushing itself up. Perhaps they helped the multi-ton behemoth push itself up from the ground after resting. Mating. Some suggest males used them to grasp their mates during the delicate dinosaur mating dance. Slashing. Another intriguing theory proposes they were used to inflict deep lacerations with their crescent-shaped claws, especially at close range. The truth is, we still don't know for sure, but the strong evidence points to them being functional, not vestigial. This is a testament to how much we still have to learn about even the most famous dinosaurs. 8. The most misunderstood speedster. Remember that iconic scene in Jurassic Park where the T-Rex is chasing down a Jeep? Yeah, about that. That was probably one of Hollywood's greatest paleontological liberties. Modern biomechanical studies, utilizing sophisticated computer models, suggest that an adult T-Rex was actually quite a lumbering giant. Its immense weight and leg structure meant it couldn't move faster than a brisk jog, topping out at around 7.7 miles per hour. For comparison, an average human can sprint faster than that. Usain Bolt could outrun a T-Rex. Any faster, and its legs would literally break under its own weight. This completely redefines its hunting strategy. The T-Rex wasn't a high-speed pursuit predator like a cheetah. Instead, it was likely an ambush hunter, relying on stealth, its powerful bite, and perhaps the ability to walk for extended periods to wear down prey over long distances. It was built for power and endurance, not speed, challenging decades of popular perception and making it a more cunning rather than merely swift predator. The debunking of the speedster myth necessitates a complete reevaluation of the T-Rex's hunting methods. If it couldn't outrun its prey, it had to rely on other strategies: ambush, a powerful initial bite, or even sustained walking to exhaust prey. This shifts its ecological role from a high-speed pursuer to a more strategic, powerful, and perhaps patient hunter, much like a Komodo dragon or a large alligator. 9. The most debated intelligence. Was the T-Rex a mindless brute or a cunning genius? The debate over T-Rex intelligence has recently become one of the hottest and most contentious topics in paleontology. For decades, the consensus was reptile smart, on par with an alligator, intelligent enough to survive, hunt, and even engage in complex behaviors like parental care, but certainly not a great mind. Then, in 2022, a study by neuroscientist Susanna Herculano Hausel dropped like a bombshell, claiming the T-Rex had as many as 3 billion neurons in its brain, comparable to a baboon. This suggested the T-Rex could use tools, problem solve, and even pass on culture. But, like a plot twist in a dinosaur movie, a new paper in 2024 by an international team of scientists, Kaspar et al., strongly refuted these claims. They argued the previous study overestimated brain size and neuron count by assuming the brain filled the entire cranial cavity, which isn't true for most reptiles. There's a lot of cerebrospinal fluid. They concluded that the T-Rex was indeed reptile smart, impressive for a dinosaur, but not on par with primates. A large animal simply needs more neurons for basic functions, and neuron density in reptile brains is lower than in birds or mammals. This back and forth highlights the dynamic nature of science. A bold new hypothesis is proposed, then rigorously tested and refined by the scientific community. This entire debate is a perfect illustration of how science works. A controversial hypothesis, Herculano-Housel's neuron count, gains attention, but then it undergoes rigorous scrutiny and re-evaluation by the broader scientific community. Casper et al.'s rebuttal, this contradiction and subsequent refinement lead to a more nuanced, evidence-based consensus. It shows that science is a self-correcting process, not a static collection of facts. For now, the T-Rex remains a smart giant alligator, and it's still pretty fascinating. 10. The most enduring icon, the King's legacy. Beyond its incredible physical attributes and fascinating biology, the T-Rex holds one most that no other dinosaur can claim. It is perhaps the most iconic and recognizable dinosaur of all time. From museum halls to Hollywood blockbusters, the T-Rex has captivated generations, sparking our imagination about a prehistoric world. But its legacy isn't just about terror, it's about discovery. Every new fossil, every new study refines our understanding, transforming a cinematic monster into a complex, specialized animal that dominated its ecosystem through a unique blend of power, senses, and life history adaptations. Consider these final surprising facts. Feathered? While not fully feathered like some smaller relatives, the T-Rex evolved from feathered ancestors. The debate continues about how much fuzz or feathers adults might have sported, especially given their immense size and propensity for overheating. The discussion about feathers highlights evolutionary trade-offs. While ancestral tyrannosaurs were feathered, immense size and climate likely led to a reduction in feathers to prevent overheating. It's not a simple yes/no answer, but a complex interplay of evolutionary history and environmental adaptation. Social life? While direct evidence of T-Rex pack hunting is still debated, other tyrannosaurs show signs of gregarious behavior. And recent discoveries even suggest T-Rex relatives performed moonwalk mating dances in mating arenas. This hints at a more nuanced social life than a purely solitary monster, even if pack hunting isn't explicitly proven for T-Rex itself. This suggests that even apex predators can have complex social dynamics. Long-distance walker? Its robust body structure suggests it was exceptionally well-suited to long-distance walking, perhaps for finding prey or patrolling vast territories. The T-Rex we know today is far different from the sluggish, tail-draggy monsters of yesteryear. It's a testament to the tireless work of paleontologists, who continue to unearth its secrets, proving that the king of dinosaurs still holds plenty of surprises. Be the ever-evolving king. So there you have it, the 10 mosts of Tyrannosaurus rex. From a bite that redefined bone crushing, to senses that put modern predators to shame, to a life history of explosive growth and a surprising social side, the T-Rex was truly a creature of incredible specialization and adaptation. It wasn't just a movie monster. It was a biological marvel, a testament to the incredible power of evolution. And the most exciting part? Paleontology is an ever-evolving field. What we consider fact today might be a fascinating new theory tomorrow. The king of dinosaurs continues to surprise us, reminding us that there's always more to learn about our planet's incredible past. Which T-Rex most was your favorite? Let us know in the comments below. If you enjoyed exploring the prehistoric world with us, hit that like button, subscribe for more amazing science facts, and ring the notification bell so you don't miss our next adventure into Earth's ancient mysteries. And if you're curious about other bizarre creatures or unsolved paleontological puzzles, let us know what you want to see next.